Exponent rules are one of the most important things that you're going to get in your math class. You're going to use these a lot, so get to know them well, understand them well. That's the most important thing, is to understand why they work the way they do. So first of all, I'm assuming you know what it means to be an exponent. An exponent says how many times to multiply the base. I'm going to go over to the answer sheet, and x to the 5th power is an example. It means I multiply x 5 times. I then multiply that by x multiplied 2 times. So it's really important that you see the addition here. Because we are multiplying, and I want to emphasize and highlight that right there, because we are multiplying these two exponential expressions, it is telling me that I am multiplying it 5 times, plus I am multiplying it another 2 times. And that's why this exponent rule provides addition. So the official exponent rule, while you don't have to use the letters B, M, and N, the exponent rule for product is when you have a product of two exponential expressions, you add the exponents. Now let's move to a very similar rule. The quotient of exponentials with the same base. So again, I'm showing you with an example of x to the 5th, and it's being divided by x squared. So I want you to see that, again, x to the 5th means multiply x 5 times. And I'm dividing that by x being multiplied twice. So what's important for you to see is that what I'm actually doing is I'm canceling these x's. You know, the old die, die. So I'm actually taking 2 away of those 5 x's that are multiplying in the numerator, and that is why I get subtraction when I have a quotient of two exponential expressions with the same base. Again, you can use the letters B, M, and N, or you can choose different letters. The idea is same base dividing means you subtract the exponents. Now, negative exponents. To understand negative exponents, we have to use the quotient rule that we just looked at. So the example I'm using is this one. Let's say I had x squared in the numerator and x to the 5th in the denominator. Now, logic tells me that I can cancel and that leaves me with 3 x's multiplying in the denominator. So hopefully we all agree and feel comfortable with the idea that x squared divided by x to the 5th is 1 divided by x cubed, 3 x's multiplying in the denominator. Now the quotient rule tells us that we are to subtract in the order of the numerator exponent minus the denominator exponent. If I do that, then I'm subtracting 2 minus 5. That gives me a negative number for my exponent. So both of these come from the same source. So this is an example to show you why a negative exponent really is just saying I'm on the wrong side of the fraction. And let me show you the rule that you need to make sure to have. And realize that with this rule, that actually means a few other things. That also means that if I have one That also means that if I have 1 divided by, let's say, b to the negative n, that means I have b to the n in the numerator. And all it is it changes the sign from being a negative exponent to a positive exponent, but nothing else changes. That negative sign in an exponent really just says you are on the wrong side of the fraction. If you want to be positive, you've got to move to the right side of the fraction. So that also means if you have, let's say, x times y to the negative 3, only y has that negative exponent. It is the only one that needs to move to the other side of the fraction. So this would become x stays where it is in the understood numerator, and y goes to the bottom with a positive 3 exponent now instead of a negative 3 exponent. This is a very important rule to understand and to get that this negative sign is not like a negative number, the way you're used to thinking about negative numbers. It is referring to needing to be on the other side of the fraction. And to really understand it better, you need to first understand why the quotient rule works and look at this subtraction order and let that absorb and make sense. Then I have one more rule to go over today. Now I have only one more rule to go over today, and that is the issue of when your exponent is 0. So I'm starting you off with an example of x squared divided by x squared. It makes sense that that's going to just be 1. But according to the quotient rule, x squared divided by x squared is x to the power of 2 minus 2. That means the exponent is 0. And if these two are exactly the same, and one train of thought gives you the number 1, the other train of thought, which is a rule that we know works, we get a 0 exponent. This must mean that these have the same meaning. So the 0 rule for exponents is if you have a base to the 0 power, that is equal to 1. Now, I want to take a moment to just add this side note that you do not have to know at a Math 3 level. This is true as long as b is a non-zero real number. So that means any number base that I have, as long as it is not 0, and it is a real number, then a 0 exponent will give me an answer of 1. And that's it, and I'll see you next time.